Hi folks, just a quick video here to demo conductivity of ionic compounds. So we know something like table salt, as a solid, it's an ionic compound because it's made of a metal and a non-metal where electrons have been transferred and our atoms picked up a charge and then were brought together by electrostatic force. But as a solid, those cations and anions are kind of locked into a crystal shape. And while they're moving, they're vibrating in place like all solids. That means they can't carry electricity because they can't really move, far, like across distances. Unlike in a metal where we have that sea of electrons that can carry a charge. Even though the metal cations are also stuck in place, being a solid, the sea of electrons can move. So let's kind of compare that to an ionic compound. So we said as a solid, an ionic compound would be an insulator, not a conductor. But when we dissolve it in water, the water molecules can take apart the two ions in the ionic compound. And so now they're not kind of really locked in place there. They're part of a liquid. They're able to spin and slide. Also, if you were to liquefy the solid table salt, they would also be able to spin and slide. So what we can do is, I've got here a battery connected to a copper wire and a zinc nail, and I'm going to put it in just plain old tap water first. Actually, let me scoot this over, and we're going to see if anything happens here. I'm trying not to get them to touch under. Okay. So if we look really, really closely, you can kind of see maybe towards the top of the copper wire, you see some bubbles. So that would tell us that we have an electrical current moving between my two metals here. And so electricity is, passing from one end of the battery, through my wire, through a metal, through the water, to the other metal, through the other wire, back to the battery. We can see the electricity is doing something to the water, and probably what it's doing is splitting the water molecule apart into hydrogen gas and oxygen gas, and that's what the bubbles are that we're seeing. So the only reason the electricity can move from one of my metals to the other is if it can flow, if that electrical current can be carried. And so it's got to be carried by something that is charged, either electrons or ions. And in my tap water here, it's probably some metals. I think the water at the school is a little hard, meaning there's some metals in it. Like if you see in your sink at home, a white kind of ring forming, or a white kind of hard substance kind of forming around the faucet or on the inside of your tub or sink or something. Here at the school, it kind of has a green kind of color to it. So I think that means there's a little too much copper in the water, probably from the pipes maybe. I've also seen the white, I think might be high levels of calcium. I should probably check that, but usually you got some metals in your water, not dangerously high levels or anything, but enough. Plus, I've been using this all day, and I probably got a little bit of salt water still stuck on my alligator clips that didn't quite dry off and is probably now in my water. So just a little bit. But let's see what happens when we move to our salt water. All right, so now we see lots more bubbling. Let's see if I can get this wire out of the way. Okay, so here we've got more ions because we dissolved a bunch of table salt in here. So we've got these sodium ions and chloride ions, freely floating around in our water here. And so they're able to carry that electrical current a lot better than the really small amounts that we had in our regular tap water. So you can really see this reaction happening. All right, so ionic compounds, when they're dissolved, are good conductors of electricity, as opposed to when they are solid, they're an insulator.